Okay, I wanted to go over a couple of problems in 5.1. The first one is determine the required value of the missing probability to make the distribution a discrete probability distribution. To remember, to go over a discrete probability distribution, the sum of the probabilities have to total 1, and each probability has to be greater than 0 but less than 1. So if you add the ones we have already, 0.22 plus 0.34 would be 0.56, and 0.56 plus 0.21 would be 0.77, so 1 minus 0.77 would equal 0.23. For question number 2, calculate this is the discrete probability distribution. Calculate the mean of this distribution. So to calculate the mean, you will take 1 and times it by 0.29, and 2 and times it by 0.18, 3 times it by 0.22, and 4 times it by 0.31. And if you see here, I did that, and these are the numbers I got. To get the mean when you have probability, you take each outcome and multiply it by the probability of that outcome, and then you sum it together, and that is how I got the mean of 2.55. The next question asks for you to calculate the standard deviation. So we use the mean to calculate the standard deviation. There are several steps. First, you will take each outcome and subtract the mean. So here I have done 1 minus 2.55, and I got negative 1.55. Then I will do 2 times 2 minus 2.55, and you will get negative 0.55 for outcome 2. For outcome 3, you take you take the 3, subtract the mean, and you get 0.45, and then you take the 4 and you subtract the 2.55 and you get 1.45. So you take each outcome, subtract the mean, and this is how you get x minus mean. Then you take each of these values and you square them. Okay, now you could have done all of this at once. You could have taken 1 minus 2.55 and got this and squared it. Squaring it is raising it to the second power or timesing it by itself. So negative 1.55 squared, or negative 1.55 times negative 1.55. So I did this for each one of these. I squared each one of these numbers, and anytime you square a negative, they all will become positive. So after you get the x minus mean squared, you have to take these numbers and multiply it back by the probability. So lots of steps here. Probability gives us more steps. So I took 2.4025 and multiplied it by 0.29, and that is how I got this number. And then I didn't round any. I just left it in Excel, so it's not rounded. Here's my formula. Negative 1.55 times 0.29. So to do the formulas, remember, all you do is you say equals, you want this number, then put your times, and then whatever cell you want to multiply it by, like the probability, and you press enter. And that's how you do it. I messed up. Let me fix that. Okay, to get this number, you would take this cell, this value, times the probability, and get this. Okay, I clicked on the wrong cell there. Okay, so there's my formula. For the next one, I took the x minus mean squared and times it by the probability. That's how I got that number, and so forth. So once you do all those and you add them together, that sum is called your variance. Okay, to get the standard deviation, this is s squared. To get the standard deviation, which is s, you just take the square root of this number, and then you round at the end. 1.203 is what I got for that one. Okay. Question number 3 is the same type of problem. So just follow the steps. There's lots of steps, but follow those. Now, for question number 4, you're looking at this table, and you're trying to figure out, is it a valid probability distribution? So is distribution A valid probability distribution? Well, first of all, is each probability greater than 0 but less than 1? Yes. Now, if you add these up, do they add up to be 1? Well, that's 2, 4, 6, 11, 12. That would be 1.2. So no, because even though each individual probability is less than 1, the total probability is greater than 1. Looking at B, okay, we have a problem here. Let's look at B and make sure. It may be okay if you 0.0, 0.1, 1, 2, 4, 8, 10. Yes, because the sum of the probabilities of all outcomes is equal to 1, and none of the probabilities are greater than 1 or less than 0. So I may have told you wrong a second ago, as long as they're not negative probabilities. We can't have a negative, okay? And they need to add up to 1. Now let's look at C. All right, everything looks good as far as a greater, less than 1, 1, 2, 3, 5, 8, 10, which would add up to 1.0. So yes, it is a valid probability distribution. C, 1, 2, 3, 5, 8, 10, so that adds up to 1. So yes, because the sum is equal to 1, and none of them are greater than 1 or less than 0. For D, we have a problem because this one is greater than 1. So no, because the probability of one of the outcomes is greater than 1. And for E, no, because even though each individual probability is greater than 0, if you add them up, you get 9, and that is 0.9, and that is less than 1.